Hello, today we're going to be talking about an optimization problem. Find the point on the curve y equals the square root of x that is closest to the point 3, 0. Now, this is going to happen in this type of diagram here. So this is what we're looking at. Now, the distance formula is equal to d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Now, the 2 points that we are considering is 3, 0, which is given. And now any point on this graph is going to be x comma the square root of x. Okay? So we want to know the distance between these two functions, or these 2 points. So that's d equals the square root of x minus 3 squared plus 0 minus root x squared. Now, we can continue simplifying this. So that's going to be, I'm going to put into exponential notation. This is going to be x minus 3 plus the square root. This is going to be the square root of x. And then when I square it, it's just going to be x. And then it's going to be raised to the 1/2 power. Now, in order to optimize this, I'm going to take the derivative and then set that derivative equal to 0. So the derivative, d prime, we're going to need to use the chain rule. We'll put the 1/2 out front, and this is a square here. Put a 1/2 out front. This is then going to be rewrite the inside plus x to the negative 1/2. Okay, and then the derivative of the inside is going to be 2 times x minus 3 plus x, or sorry, plus 1, because we're doing the derivative. And so this is my derivative. I'm going to rewrite this so that when I set it equal to 0, it's a little bit clearer. So this is going to be, the top is going to be 2x minus 6 plus 1. And then the bottom is going to be 2 times quantity x minus 3 squared plus x to the 1/2. Now, the derivative, d prime, equals 0 whenever 2x minus 5 equals 0. Now, the 2x minus 5 is what happens when I reduce this. So let me rewrite that here. 2x minus 5 all over the stuff downstairs. So that's x minus 3 squared plus x to the 1/2. Okay? So to solve this, I'm going to add 5 to both sides. And I get 2x equals 5. Divide both sides by 2, and I get x equals 5 over 2. And so what that is saying is, when x equals 5 over 2, or 2.5, we will have the x location for the minimum distance between 3, 0 and x equals 2.5. And so then, the point on this curve here that will be closest to the point 3, 0 is going to be, x equals 2.5, y equals the square root of x. So evaluate this at x equals 2.5. That gives us the square root of 2.5. So what that is saying is the point on this curve for the closest distance to 0, 3 is going to be at 2.5 comma root 2.5. And so that is the answer to this optimization problem.